sleep. So this time the topic is DHT version 2, and this is the last thing. Damn it. There we go. Okay, so what's our motivation? Now right now, our biggest inhibitor of scalability is Gluster. It has the behavior of broadcasting its operations to all other nodes, requiring all other nodes to be consistent, without taking a whole lot of measures to make sure that they actually are. So, KP is going to be given a talk on that later. After that, our next biggest inhibitor of scalability is probably DHT. And the problem there is that while DHT uses a great algorithm, does some things very well, it has a behavior that if it looks for a file in one place where it's supposed to be, what we call its hash location, and it's not there, it still has to make sure it's not anywhere else. I mean anywhere else. Particularly in the case of something like a rename, we really do need to know whether there's a copy on any brick. So what we do is we look at the hash location, we get a negative answer there, we essentially do a broadcast to all bricks and see if anybody else has it. There's a couple of cases in which we tweaked that. Very recently, in fact, a patch went in that would say if we know that this directory has been fully rebalanced, and since the last time the topology changed, since the brick was added or removed, then nothing could be in the wrong place. If it's not in the right place, it's nowhere. Therefore, we can skip that. But that's kind of an optimization that only applies some of the time. If we've added a brick and not done a rebalance, it doesn't apply.
Actually, the complete one rebalance, you will run the situation. The window of time after you fix the layout, but actually you are not moved the place to
right. You have to do the full rebalance.
So that's not an optimization actually. It's the proper. It was actually a bug that you have to fix everywhere all the time. So the patch you're choosing is actually a bug fix, not really an optimization.
Well, but there are still cases where we have to look at it.
Only if you are doing a rebalance, only if you have that. Otherwise, it's not. There is no fundamental necessity for whatever.
Okay. So related to that is the problem of directories existing multiple places. So, for example, if you do a rename, you may be renaming so that the file already exists on one node. A link file may exist on another node, another brick. Managing all of that has been the source of how many bugs? And Xiang and Du and others have spent just a ton of time chasing all these down because the logic there to deal with all of the link files that did exist, all of the link files that must exist, and so forth, gets pretty complicated. Xiang, as I mentioned earlier, was actually supposed to be the one giving this talk. So, as has already been pointed out, I'll get some stuff wrong. These problems do inhibit our scalability. As difficult as some of these conditions are at our current node counts, say low dozens, as a common maximum size. I think the largest size that Red Hat storage will officially support is 64. Is that still true?
128. No, 128.
Oh, Red Hat 128. Okay. Now, of course, the community version, we know we can actually do more. But as difficult as they are at those kinds of scales, they're going to be absolutely intolerable at higher scales. They're going to happen more frequently, and the effects are going to be more severe. And dealing with these, even as well as we do, increases the complexity of the DHT code enormously. And there's all of these sort of special code paths to deal with the fact that information that is in one directory may actually be splattered across every brick. Rhetoric has a slightly different interpretation of that information. So we're looking at making several categories of changes. The first one is that we're thinking of separating data and metadata. As I said, there's one stupid graphic in each of my presentations. That's the no one ring to rule them all. There's now two rings. There's one for data, there's one for metadata. So directories are essentially sharded across some set of nodes. Files are sharded across some set of nodes. They could be the same set, they could be disjoint. Probably the most common deployment model would be that the directory nodes are a subset of the file nodes. So the idea there is that we don't want to have a single metadata server hotspot. That's always been one of our major differentiators versus some certain other lame distributed file systems. So we don't want to go that far. On the other hand, having it be everywhere has also proven rather difficult. So we want to have our metadata, our directory data on a relatively small set of nodes, more than one. So it's kind of a Cinderella, not too big, not too small, somewhere in between. The other thing is, with the metadata separate, we could actually gain ourselves some freedom in how we represent it. That it doesn't have to be actual directories and actual files and an actual local file system. We could actually put all of this information in a database and gain some capabilities. Because there's much more powerful querying capabilities, there's stronger transactional guarantees, etc. So we're looking at doing that. We're probably not looking at doing the database part until we have a feel for how just splitting the data and metadata work out. And it would be silly to design that piece, choose a database, choose a schema, do all that implementation based on a workload that we don't even understand. So it's not until we've actually done the data and metadata split we'll understand what that workload really looks like. Another thing is, this is probably the most important part, directories are not going to exist globally. Files don't exist globally, why should directories? There's a good reason why we've done this for files. We're going to do it for directories as well. So the idea here is that each directory lives on one subfile. It doesn't mean a single word because of things like replication. That we still have some redundancy, some protection against failure, but it's going to be a small subset of the nodes. So any operation involving that directory only needs to consult that one subfile. If it's a rename, if it's a create, if it's a remove, there's only one place to go. We don't need to coordinate a related series of operations across the source and destination of a rename and things like that. So that's hopefully going to make things a lot simpler. The other thing that this sort of does for us, in combination with the next change, is that it makes named and nameless lookups look a lot more similar. Because the next change is that the back end is going to be based more on GFIDs rather than names. To get to a file given its GFID, all we need to do is traverse that top level set of directories that exist in Gluster FS, which we already have. We already need to have that for nameless lookups. What we're proposing for DHT version 2 is that that's all we have. That the directory copy that exists on one subvolume, what it contains are what we call stub files. A stub file contains the mapping from a name to a GFID. So it says within this parent directory, this name XYZ will map to a certain GFID. It might have a hint about which subvolume that file or subdirectory actually exists on. That need not be actually correct, but it's going to be the first place we look. So it serves a function a little bit like link files do today. It might also contain a cached or eventually consistent copy of certain metadata. So for example, when you're doing a read dir plus, you want to see things like M times, C times, maybe even sizes. You don't necessarily, in all use cases, need that to be exactly up to the millisecond, microsecond correct. You don't need to be entirely consistent, but you want to be able to get some information back without having to do a separate stat call to a separate subvolume to get it. So the idea is that when changes to these values occur, the file itself is authoritative. That's where the real M time is. That's where the real file size is. But that information is lazily propagated in the stub that exists in its parent directory. So when you're running read dir plus, you get an almost exactly up-to-date version of that information without having to consult another subvolume. Some of the things that we haven't worked out, I admit this is still a work in progress. One is, given this structure, how do we build the ancestry of the file? Because we do need to do that in several cases. We ultimately need to be able to get back to its original path, given its GFID. Get back to an original path, because with hard links there may be multiple. Another thing is, I think I heard this was mentioned by you Facebook guys, that you actually like the fact that the brick backend reflects what the user visible view, being able to manipulate that is valuable. Agreed, it is valuable. We need to find a way, perhaps using tools or libraries, to be able to get that view without actually doing the full mount. Be able to browse that directory structure, see things, fix things, etc. I want to be a little bit careful with that because one of our continuing sources of pain has been users actually do go and mess with stuff in the bricks. And they mess with stuff in ways that are inconsistent with how our software actually works. And terrible things start to happen. We get GFID mismatches, we get some forms of data corruption, all sorts of fun, missing files, split brain, etc. So we don't want to necessarily provide a general way to go and mess with stuff on the back end. But certainly being able to get that view and see what's there is valuable, and we need to figure out a way to maintain that. Another change is that right now we store layout information about how files are distributed, the hash ranges, across every copy of the subdirectory on every brick, or every subvolume. So if you have a three-way distribute, then subvolume A contains information about the hash range that it's responsible for, subvolume B contains information about its hash range, subvolume C contains information about its hash range. We have to go query all of those, combine those into a full layout, and this is where all that stuff you see in your logs about holes, anomalies, overlaps, that's what that's all about. Is that we're trying to take this information that actually exists on disk in multiple places, on multiple bricks, and combine it and make sure it's consistent. What we're looking at doing in DHT version 2, since we don't actually have copies of that directory on multiple subvolumes, clearly that approach just isn't even going to make sense. What we're looking at doing is actually taking the layouts and storing them in a different way. Now, the obvious thing to do would be similar to what we do now, that each directory has its own layout, but that one copy of the layout contains the complete map. So it's going to be a pretty long X adder if you have a widely distributed volume. It's going to have to contain information that says, for each of our 100 bricks, they're claiming this range, this range, this range, this range, this range, this range. That's kind of awful. It also doesn't solve another problem we have with the current layout family, which is that in order to do just the fixed layout part of a rebalance, you have to go touch every directory in the volume. And that is actually a non-trivial amount of time, even if you're not moving any data. I mean, that's later. That's migrate data phase rebalance. What we'd like to do is actually store one copy of the layout and have directories refer to that by some name or ID and possibly a history or generation number, so that when we want to change the layout, we just change it. Boom, it's in one place, we changed it. Everybody else automatically picks up that change. So fixed layout becomes like a 5 millisecond operation. That would be kind of nice. So that's an improvement. The other thing that goes along with that is now that we have a more compact, more guaranteed, consistent place to put that layout, we can actually start storing multiple layouts going back in time. So here's the layout now, here's the layout before we added that last couple of bricks, here's the layout before we removed the brick before that, etc. What that lets us do is we can totally avoid any case where we need to go check everywhere, even in the rebalancing instances. Because there's only so many layouts that could possibly have applied to this directory. There's only so many places that file could possibly have gone. So we only need to check that many. As we actually do finish rebalancing, we can start retiring old layouts, which we know no directory anywhere has any files to replace according to that layout anymore. So it's a finite set. So that actually helps us a lot with dealing with layout changes in a much more efficient way than what we have now. If you add a brick, you add a new version of the layout, that's a very quick operation, it happens one place. Eventually, at some point later, you migrated everything to that new layout. You can now retire the layout before, which is just deleting one entry in whatever database or XAD or whatever we're storing layouts in. So that's very quick. And yet, we're still short of the same correctness that we have now. Or perhaps even better. The other thing we're looking at adding is having layouts include virtual nodes. How many people know about virtual nodes in consistent hashing? Okay. So the basic idea here is that instead of giving each brick one hash range that it's responsible for, we give it multiple. And the advantage to doing that is that with the current scheme, particularly if you're using the hash range, I should have drawn a figure for this, I'm sorry. If you're using the hash range to determine where the replica sets up, then if each node only has one place on the ring, then everything that it's responsible for has the same pattern. That the second replica is all going to be on exactly one other node. So if that first node fails, all of its load fails over the second. With virtual nodes, that's not the case. You can actually place the virtual nodes so that when node A fails, part of its load will fail over to node B, part of its load will fail over to node C, part of its load will fail over to node D. Now, down at the next level, that means that we have to be setting out AFR or erasure code instances for each of those. That's easily enough done. But it gives us a much better framework for choosing which files are replicated in there. We can sort of do away with this static. All files that exist on X are exactly replicated on Y and nowhere else, which is actually something that a lot of people sort of complain about, that it creates hotspots. So again, related to this, overlapping replica sets. It's the same issue. You want to be able to say that you're not just using, if you're doing two-way replication and you have 12 nodes, you have exactly 6 places where a file might be. It's on A and B, it's on C and D, it's on E and F, etc. Only 6 possibilities. We want to actually have more possibilities because that spreads the failure load around better. It also potentially spreads the self-heal load around better when we're trying to repair after things come back. So we're looking to do this. This is going to require that Gluster D be a little bit smarter about using this more complicated hash ring to set up all files that include more replica sets that are using the sub-bricks within a user brick. But DHT itself has to be involved in setting up that layout for Gluster D to use. shown was that we have some pretty bad interactions between rebalancing within DHT proper and tier promotions and demotions in the tier translator. They're doing very similar things, but they're kind of stepping on each other a little bit, both in terms of trying to do things simultaneously and in terms of sharing code but having special cases because they're not really quite the same. So what we'd like to do is abstract that out into a library that both can use so that there's a more clearly defined interface to this common functionality. As we were talking, some of us were talking at lunch, that's something we're looking to do throughout the code base, is take these cases where we're doing almost the same thing in 6 different places. Somebody picked up the code from one place, copied it, modified it, somebody else copied it again, modified it again, and start defining real generic core functions, library functions that translators can use to do common things. Another example of this that has come up is if we wanted to have AFR or erasure coding or NSR running on the server side, they're going to need to do some very, very, very similar things in terms of quorum, in terms of checking whether we have quorum when an IO comes in terms of fanning out requests. That should probably be in a common layer rather than one that's copied between the 3 translators. I don't know if we're actually going to go that route, but it's an example of trying to take what's currently duplicated code and refactor it into well-abstracted, reusable code. So the next translator that comes along that does something similar doesn't need to reinvent yet another version of almost the same thing. That it can either use what's there in place or perhaps enhance it a little, so that we're all using and testing the same piece of code rather than citizens. And that's it. Questions? Yes.
So for the same path, if DFID changes, so the hash value again changes and has to create a link file and multiple numbers problem will be there. Like for example, if you open a file in a VI, we enter modified and save. So it creates a temporary file and renames it back to the original file. So at the end of it, you have the same file name but the different DFID. So if you calculate the hash again, then it may fall into different ways.
Right, and that's why this stuff will contain a hint. Much like we currently have with link files, a file might not be where it's supposed to go according to the hashing scheme. So by including that information in the stub, we can identify that that file is on the wrong node and identify which one it is without having to do the broadcast type of work.
But the stub to be created in the new node.
The stub would be created at the parent directory of stub.
Also, we need to prepare 2 records to actually get to the file with the data.
Not generally. There may be cases where that's necessary. And generally, you're getting to a node by doing a lookup on its parent by name, right? So when you did that, you already got that hint.
No, but in at least the current scheme, we don't have directories everywhere. It doesn't matter what is the hash of the directory, where it is from, because the directory is going to sit everywhere. But now it all depends on what is the hash of the directory and hash of the file. I mean, if both of them are the same, then only it will be relatively same.
It normally requires 2 months to follow the process. That's how you have to resolve it.
Yeah, you would have to resolve the parent, right?
Sorry?
You would have to resolve the parent first for getting to the base name. So,
Right. We already had to resolve the parent, so that's already cache. Richard, you had something?
Yeah, so
I was waiting to get on this one.
so I was wondering, why not go to, the Exodus maintainers, Dave, and say, and I know they have this thing in Exodus where they you not make it so metadata can simply live on a different block device and then, you solve it through hardware, or at least look at you even look at it as having whatever solution that's we would come up with to solve the metadata issues or the small I/O issues. It at least should be similar performance to that. Because sometimes I look at this and I'm like, is LevelDB or these SQL-like databases going to be better or worse than if XFS and ButterFS simply handle it themselves on a different block device, so it's just fast. Because usually that's what people end up doing with these things, is once it goes into LevelDB, then the natural thing people are going to do is I'm going to stick it on Flash. I mean, really LevelDB maybe didn't make that much of a difference. It's really, they stuck it on Flash, so it really makes a difference. So.
Well, part of the reason is that we need to be local file system independent. So we would need to have that capability on all of the file systems that we typically run on top of.
Okay.
So there's at least 5 of those. There's XFS, DHT2, ButterFS, ZFS, and whatever the hell is on that BSD. I don't even remember what it is at this point, but we do run that as well.
UFS, yeah.
And part of it is that even if we support that, it may not give us some of the capabilities that we get from the database, in terms of queryability, for example. So we may be able to get some wins there, but I don't think we get all of the benefits that we might get from doing it as a database. And there's certain, I know you're going to do the same thing for X editors.
Yeah, they could do it. Fundamentally, these are their databases, right? When they stick that, when they're sticking in tables which are similar data structures to which these databases end up using anyway. So I kind of look at it as at what point are you reinventing the wheel, and just resolving problems that.
Well, we're not thinking of writing our own database, that's for sure.
Yeah, but reinventing a file meta store that let's face it, all the file systems have sadly re-implemented 7 times, but.
Yeah. Well, it's something we're still looking at. And if it turns out that it's not beneficial, then we wouldn't go that route. But we would have the flexibility. We would have the flexibility to use a database. We would have the flexibility to use any special file system features. ButterFS already has transactional behaviors that might be useful to us. But those don't exist on other file systems.
Yeah.
So if we abstract it out, we make it possible to use those where they exist, and then fall back to a more generic mechanism where they are.
You're still file system agnostic. It's just people get, if you run XFS, so you really need crazy metadata performance, you really, then these are 2 file systems that will get you that, for example, right? And that's the where people think when they pick file systems, you're going to get performance characteristics.
Yeah.
Analyze this stuff.
Quite possible.
Yeah, I think.
Yes.
And the changes that we are talking about, this will all still go in DHT, right? And then if I ever want to handwrite my WAR file again and have no DHT anymore, will I be able to do that?
Will you be any more or less able to do that than you are now? And this is a change to how DHT works. I don't think it's a change to how it interacts with other parts of the system. Yes, if we start doing overlap and replicate groups, then that's actually you could actually do the same thing today by rewriting a call file. It's something that can be duplicated. In fact, that's what HackFS did. HackFS took the bricks that were defined in Gluster as part of the volume, created subdirectories in each of those bricks for each tenant, and then created new DHT ball files across the subdirectories. And amazingly, it worked.
So I think the other thing that we could do is to actually, when we do this re-implementation, right? So we could have that as a new shared library, say DHT2.so or something like that, so that You could always load DHT if you prefer using that. So
Yeah, my question was not having even DHT, the old DHT in the workflow. I sometimes have just views and POSIX.
sure.
Yeah, so that should still be working.
Okay.
Yeah.
Yeah, that
No
would still
reason
work.
it
Yeah.
shouldn't work.
Yeah.
I can't think of any reasonable way to make DHT server side. I don't see how that makes sense. So yeah,
Yeah, so for example, as of the change log, we don't have a single entry point. We record it in all the breaks. So there are several problems with composite operation rename and those things. So we have it as a separate site and have a single entry point that.
So yeah, so there are some places where you need to have a cluster view. Currently, for example, the quota enforcement place wants cluster view, though it is on the public server side. So same thing, change log also has some issues. So the earlier what already proposed, so it had a proposal to servers having a global view, which they cluster by view. So that was, so there are a couple of requirements where the servers would need to.
yeah. Also, there's a single point of failure.
Yeah.
And yes, we have to satisfy those use cases. I don't think going to a single metadata volume is the way to go.
No, this one.
Yes, Pete?
You can optionally say the one file which does have ASC, you can run a day with the constant graph in the server side. Nobody's talking to you.
You could, yeah.
So there's nothing to do internally.
No. IO has to also pass through such a graph. That's the problem.
Yeah, so
Having so what happens is there are two clients.
No. So all of the IO has to pass through a graph where quota, geolocation, etc. sit above DHT.
on the server.
So then there will be one server that will do DHT.
No. All the so let's consider NFS servers where it is existing on all of the servers based on who is mounting where IO goes through the server. Similarly, we will have mount servers running everywhere where quota translator, geolocation translator, etc. They actually sit above DHT so that they always have a cluster view for making decisions. So that all these corner cases where something happened just here but not on this big kind of problems over there.
But isn't the quota case? Isn't the quota case addressed with the presence of quota D, which acts as a specialized client for
No, it is
quota?
not the case of the
It's
so
not-
that's still multiple one servers.
Yeah.
No, but it always has a complete size.
That's a complete site at that point in time.
No, so when it updates the quota size of a directory, it is going to be propagated to all the parent directories. It does not have to rely on whether, okay, on this brick the size has updated, but on this brick it hasn't.
No, but
Aggregated to by default, but
how is it different from the quota D scheme that we have today?
It is not handling the IO part.
Why?
IO does not go through quota.
Why would you want quota D to do that? I mean, so I don't see a special advantage with just loading quota. I mean, quota D like behavior in quota and things.
No, so quota translator itself should just do one updation of the sizes and it should reflect on all of the bricks. It should not be like, which brick is doing it every time.
Sounds like we have identified the people who should do a breakout session at some point.
Yes.
I think
Yeah,
so.
so we need to discuss on this.
Yeah.
Even this ISI is going to sit where it is
IO sizes?
ISI, the file size. So if you do a lookup, you only get the. So basically there is this concept of stub, right?
Right.
So will the stub also have ISIs?
I could go either way on that, which should probably be an option.
Yeah, because if it is not.
If you need it to be absolutely positively up to date, consistent, current, then you're going to have to go to the place where the file is to get it.
Yeah, but that is referred to.
However, for most use cases, that's not what you want. For most use cases, especially where you're using Reader Plus, you want a reasonably correct current value, which can be lazily propagated. And you can get that without having to go to where the file lives to get that, if it's propagated into a stub.
So what happens in the fresh mode in that case? So basically, if you do a stat of file 1 slash file 1. So once, let's say that file 1 stub and file 1's actual data file are not in the same bit, then it will require 2 lookups, and it is not something in our hands, right? Whether it will always stay in the same record, because the hash is it's based on the record.
Okay.
Yeah, so it will require 2 lookups to do a stat for normal IO as well.
Yeah, basically, but I mean, we don't have that now.
Not in the
Right now, if you want to list a directory, you have to go hit every break.
not listing a directory, just a stat on file.
Right, if you're doing just a stat, that's a different case. I'm talking about if you were doing read plus, which is a common type of thing that people do, you don't necessarily want to be going and hitting every break. If you can do a read plus entirely on one directory, on one break, that's a game. Now you might not be getting perfect information. You'll be getting near perfect information, but you'll be getting it more quickly. Yes.
So what happens if someone, what if someone puts a really, would that expose like imbalances in the cluster if you've got certain things that, when someone makes like a 2 terabyte file and then just happens to hash to that, subvolume, or, say people get unlucky.
Well,
There's something we've seen like, I guess in the
yeah, I mean, we've seen this now, that if you have very large files and very few bricks, it's pretty easy to create an imbalance.
Yeah.
So unless you're using striping, which we're deprecating. So yeah, I mean, it's definitely a problem.
So that seems to be making it worse because someone can just, it's more common that big single directories exist than single files.
Okay. Yeah, that is a potential. Unfortunately, sharding an individual directory like Giga does from CMU, it's a whole new challenge. Well, I'm getting the big stop signal from Tom. Sorry. So, thank you.
Thank you.